Hi everyone, welcome to the final webinar in our Life of a Color series. This final topic is on production and quality control. Once again, Tim Mao will be presenting our Applications and Engineering Technical Support Manager. I'm Robert Grotans, the Global Technical Marketing Manager, and I'll be moderating today's webinar. Just a few things to go over before we get started. Due to the number of people that are attending this webinar, we will keep everyone muted. If you have any questions, please feel free to use the questions panel on this page, and we will follow up with you after this webinar. This webinar will also be recorded, and we'll send you a recording to this webinar the next day. So with that, I'll turn it over to Tim to get things started.
Thank you, Robert. So let's dive into the Life of a Color, our fourth and final presentation in this series, talking about production and quality control. So if you've been through following along through the first three of the four-part series here, you've seen this before, the color workflow, really the life of the color. So we've been already through inspiration and ideation. We've been through color specification, through the conflict of going from specification to pre-production and formulation, being able to validate we can produce the color. Now we're in that last one on the far right, production. We're literally going to manufacture the final product and hopefully provide what our customer needs. So let's move along. And again, another reminder, what we were working on was a seasonal version of an iconic toy. And that version of that toy was going to be made using these colors. And again, as we did when we were doing the formulation piece, we're going to focus today on that particular one outlined in orange there that we called Epiphany, and that particular color in this. So let's dive in and talk about what we need to do if we're doing production in QC. So we've got a number of things to be concerned with. Number one, we've got to make sure we understand the standard, the reference, the color we're trying to make, Epiphany in this case, that we're aiming for the right thing. The second thing we've got to think about is the tolerance, and a couple of things about the tolerance. First of all, what tolerance are we going to use? And of course, tolerance simply means how much difference is acceptable. So it's got to be something that ultimately the customer will accept, right? That tolerance must be defining that. And then we also want our tolerance to be actionable. We'll talk a little more about that. We're going to talk a bit about process control to help us understand why our color might be varying in production, and ultimately even talk really quickly about how to fix that bad color, that color that doesn't pass the tolerance. So let's talk about the standard a second. There's really two main ways we can get that color standard. It can be given to us or distributed digitally. Could be a Pantone Live color, could be a CXF file that somebody sends you or emails you. It could also be a job file, either coming from Color IQC or Color iMatch. So if we're following the workflow, as we did in our third presentation in this series, we were using Color iMatch to formulate the color. Well, once we've got that done, that iMatch job contains the color standard. I could share that job with somebody who's going to be using IQC in production to ensure that they're aiming for the same target, the same standard. Now, we can also, of course, measure the color standard. So sometimes we're given a physical sample and we can go ahead and measure that with a benchtop device, a countertop device, a handheld device. There's a wide variety of options there. So we've got our standard established. Now we need to establish a tolerance. And as I said earlier, it really needs to be something that is in agreement with what the customer will ultimately accept, and whoever that customer is. Might be a consumer, depends what I'm producing, right? If I'm producing this, in this case, that stacking toy, the color has to be what's acceptable to the consumer. And so we might decide on a tolerance about that. We've got multiple webinars out there that you can get on demand that talk about tolerancing in detail. We're not going to do that today. We're just going to say for this example that we're going to use a Delta E 2000 tolerance, and our tolerance limit is going to be 0.8, meaning less than 0.8, those samples will pass. If it's more than 0.8, they're going to fail. And here we see our Epiphany. I've got 16 samples measured. on the left side of the trial name there, you'll see a green or a red circle. That obviously the green one's passed and the red one's failed. The numbers are there, so I can be doing production and I can assess it and say, hey, I've got some pass and some fail. But I've got to be a little bit careful, because some of these samples that say pass, for example, the one at the very top, sample number 2, has a delta E 2000 of 0.43. Okay, my tolerance is 0.8, so it passes. Yep, it's in pretty good shape. Now look at the second one from the bottom, sample 15. It also passes, but it's 0.75, so it's really close to failing. So that's at 0.75, sample 15. Sample 14, the one right above it, failed. It's at 0.81. Those two samples are only 0.06 apart. We probably, depending on what direction they're off, they may look very, very close to one another, yet one passes and one fails. The point here is that a tolerance can't be a knife edge, right? Good doesn't suddenly become bad by shifting 0.01, yet numerically it might. So how do we make it actionable? We're going to add, in the software, we have the ability to add what's called a margin. And so here we added a 10% margin. And what that means is that if a sample gets within 10% of failing, in other words, if it's within 0.08 of my tolerance of the 0.8, right? So at 0.72, right, it's going to switch from saying it passed to its margin. And now you'll notice I have a couple of samples that are labeled as margin. Their little icons on the left are yellow. And what that's telling me is, hey, I need to pay attention. I've got a tolerance now. When it's green, I can be really confident that that color is good because it's a significant percentage. I've chosen 10% here. It could be a different number. You might choose 20%. And then if everything that's green, that comes up green and pass, you're pretty confident that color is going to be good. There won't be any dispute between different observers, for example. But if it's yellow, it's telling me be careful. You're getting close to failing, especially if I'm testing production over a run and I'm looking at trends and I start to see things trending from being good to moving closer to and closer to failing. I go from green to yellow. It's a call to action. That's what we mean by making your tolerance actionable, and it's really critical, because then you can hopefully, if something is causing your color to start to shift or drift, you can stop whatever is causing that before it drifts from pass to fail. That's making it actionable. Now, in order to do that, we also need to consider process control. So here we're showing another instrument. This happens to be a Varicolor Spectro. That device can actually be used in line. In other words, if I was extruding something plastic and long bits of it are going by on a conveyor belt, or it's being fed by, that instrument can be measuring as the product goes by, non-contact. So we show that because it's something used in process control, but it can be done with laboratory equipment as well. So to do process control, now we want to start to not just look at the color difference, but also assess the impact of some of our production variables. So here it's a different color. Now it's not Epiphany anymore, it's a pale yellow color. And I have the same kind of data we were looking at before, passes and fails and all that kind of stuff. But now you'll see there's 3 columns at the right edge of the data there that say temperature, production line, and shift. And I just made those up and put them in here to use as an example. But we have the ability in the software to capture what we might call metadata. So it's data about those particular things that might reflect something about how they were produced. For example, the temperature that the product was manufactured at. At some point in the product, maybe I've got a temperature sensor that's measuring it during some stage in the process, and I'm recording that. Might be which production line it was produced on. If I have multiple lines making the same thing, that's a variable. Which shift it's being done by. There's any host of things. I just made these up. You can use whatever you want. But if I have the ability to capture that information, then maybe I can figure out what might be contributing to this trend at the bottom, where I'm going from green to red to green to red, and so on. So with this in place, what I can do in the software is I actually going to click on the temperature column and have it sort by temperature. So it just sorted them. And you can see, look, all my passes fall right in the middle. In fact, I can say if I'm between 200 and 220 C, my color is good. But if I'm below that or I'm above it, my color fails. Now, again, this is simulated situation. I've made it very, very easy for us to detect that. It's never going to be quite that clear, but you may find that it's a combination of things. Oh, we have a temperature issue and it's always on the night shift. In fact, this is a real world example I had. We had a temperature issue on a night shift on a particular day of the week. Well, why? Because this particular plant shut down on weekends and the night shift was the first people to come in early, late Sunday night, early Monday morning to start things up, and their color they would have color problems then because the plant wasn't that temperature, let alone the materials and the equipment. So looking at assessing variables helps us to understand the why. Otherwise, we're only going to know, yes, your color is good or bad, but it's good to understand why, because then we may be able to do something to fix that. And then ultimately, kind of going back to our formulation that we talked about, formulation can get used in production as well. And where it might get used is if we're producing batches of things. Maybe we're making paint, right? We're not molding plastic, we're making paint. Well, I might have a batch of that paint that comes in and I test it. My tolerance is still 0.8. I test my batch, it comes in, as you can see here at, this is Delta E CMC, 1.01. Okay, that's gonna fail. Well, what am I gonna do? If I've got the formulation software, I can go calculate a correction to reduce the Delta E from 1.01 to 0.14 by adding this much to my batch of paint. And I can adjust the color. So we may be able to calculate a correction if the color is too far gone, right? The formulation software can also help us recycle that material if we need to. So formulation has a place in the production environment as well, depending upon what we're producing, right? Obviously, if I'm measuring a molded plastic product, by the time it's molded, I can't correct the color of that molded part because that color is done. So there's different places in the process where it might make sense depending on what you're producing. But ultimately, we're going to have a color standard with a tolerance, we hope, that's actionable, right? So that tolerance helps drive us to action when we need to. We're going to track our process variables and in some cases be able to even adjust color from bad to good using iMatch software. So that takes us through production and QC and how we manage color. And so with that, we're going to turn it over to Robert and open it up for you to take some time to pose your questions.
Thanks, Tim. Thanks everyone for joining. This will wrap up today's webinar. If you have any questions, we will leave some time for you to go ahead and submit those questions. If you missed any of the webinars in this series, we will also be sending out a link to all of those webinars so you can catch up. If you would like, at the end of this webinar, we will also be displaying a polling question. If you would like to speak to a salesperson or even someone like Tim to learn more, you can go ahead and answer that and we'll get you in touch with the correct person. So once again, I would like to say thanks everyone for joining this series. Have a great rest of your day and we hope to see you soon in the next webinar.